Today I'm going to show you how you can embed Lua inside your C++ application with the help of the Sol2 library. So first we will cover the setup, then we will write a small hello world program. I will cover the basics, and then we will look into how C++ can call into Lua and how Lua can call back into C++. I will show you how you can bind classes and their methods so that you can use those inside Lua. And then I will show you an example of how you can use Lua as a JSON alternative. And in the end, I will conclude the topic. First, we're gonna need to download Lua. So by the time I'm making this video, this is the 6th of July 2020, a new version of Lua has been released. This is the version 5.4. But I'm not gonna use this version for this video. I'm gonna use the slightly older one because I know that this works. So I will download the file, and then I will head over to Sol2. So Sol2, you can just go to github.com/thephd/Sol2, and then we will go to releases and we will grab the latest release available to us. So we will grab source code, right? I will paste them here. I will create a basic project structure. I will call this externals. I will put Lua there. Let me rename this to Lua. And I will put Sol2 there. I will use the single file header, which is actually two files, so they have also a forward declaration header. So you copy it here. Next, I'm gonna create a source folder. Do we gonna need? Yeah, we will need something for the CMake file to generate the thing in. So this is this. I will explain this later. And we will create a CMake lists file. Cool. So this is the first thing we're gonna do is we will create the project structure inside the CMake. Let me paste something I have already prepared, so we can remove this. We can give the project a name. Let's call it, I don't know, Lua Sol example. Most definitely this is the sandbox. We will need the Lua source directory. Actually just need these two things. So next we're gonna do the following. We will create the library for Lua. We'll just call it Lua. We will compile it statically, and we will need to add the following source files to the library. So these are just these things. If you go inside here, so it's inside the Lua folder. These are all the C files you need to include. I already did the work and put them already here. Now that we have Lua, we can define our executable, which we will call sandbox, and we'll have the following source files. It will have main.cpp. Yes, that's enough. And we will add target. Oh yeah, so, and yeah, I forgot, obviously, I forgot to define the externals folder, so this is why I was so hesitant. This is the project directory, and this is just the externals. And from here we have access to Lua and Sol2. So from here on we need to say target include directories, and we will say sandbox, and we will give it the private externals. And we will add target link libraries, and then we will link Lua to it. We can go inside the VSS studio. We can run our batch file. No sources given. Actually, I did give you all sources. It doesn't work because we did not put a source file here. So this is main.cpp. Actually, I don't know. It doesn't matter if it compiles or not, but let's add it here to be safe. So it should be externals and it should be project source directory. And now we can go inside our BSS Studio file and folder, and then we should see the solution file, which we can open up with Writer. Let's check what's going on here. Let's include stdio and printf something. Hello. So now this should compile and run successfully with Lua. Now we've completed the setup part. We verified the project file, so let's write a hello world application. So we want to create a Lua state using Sol2. So they have a cool example here, which is this thing. You grab this and we paste it here. So if you do this and you compile, it doesn't compile, it complains that it says unsupported Lua version. So what you have to do is you have to include Lua before you include Sol. Lua HPP. So if you now compile and run, it should work fine. Yeah, so this program doesn't have an output. So what we're gonna do is we're gonna define the Lua state, and we're gonna just say Lua script, and we're gonna say print hello world. However, we will need to include the base libraries for Lua. I think we can actually remove this and just use the base. So if we run now, it prints hello world using Lua. And with this we conclude our hello world example. Let's move onto the basics. So next what we want to do is we want to call Lua functions from C++, right? So we did this. What we can do next is we can do the following. We can say function say hello print hello world. Now we can end it, and we don't need this. What we can do here is we can call this function like this. If we run it, it should say hello world, which it does. So now we want to call C++ functions from Lua. We will define a cpp func. We will say cpp func called. What we want to do is we want to expose the C++ function to Lua. To do this, we can do the following thing. We can say set function. We give it a name. Let's just call it cpp func as well, and we have to give it a function pointer like this. Now this is registered to Lua, and we can inside of Lua call it like this. So that works. What we can do next is we can call from C++ to a Lua function which takes an argument. So let's say hello uses a parameter which is, I don't know, a number. Let's just call it num, and we want to print it here, right? So if we run this, it should print nothing. It just prints nil because it didn't receive anything. I mean, we could in theory just come inside here and say hello world, and this works fine, but we want to put in a parameter inside there. So what we can do is we can do the following. We'll have a function which is of type std function void. It comes from here. So if you access Lua like that, the Lua object, you can pass in a function name. This way you can retrieve a function pointer to C++. So if I do this now, see, it will print nil again because I'm not passing a parameter inside of it, but it's printing it. So to fix this, we want to define the parameter we are passing in. So let's say this is gonna be an int, and now we will pass in, let's say 10. We can make this constant. So now this should print 10. And now let's maybe show how you can run a script. So for this, let me add a script file, and let me add it to the source as well. So we're putting it right here, Lua the script, so this way it will show up in the thing. So because I'm gonna read the file from where the executable is located, which is gonna be inside this folder, and the script file is in the source, we have to set the debugging start directory for Visual Studio. So to do this in CMake, we can do the following. There's a property. You can put it on a target, so we're targeting our sandbox, and then it's called VS debugger working directory, and we pass in the sandbox directory so we can find the script file. So in here we're gonna put print script file loaded, like that, and down here we're gonna say script file, and we're gonna say script.lua, and this should execute the script we just. It cannot find a lua.script. There's a typo. So yeah, now we can regenerate, we can run it. And now you see the script file is loaded, and the cool thing is that the script file already can access this stuff. So we can go inside here, we can call our cpp func. What's even cooler is that you can define a Lua function inside here. I don't know, just print Lua func called, and you can actually call the Lua function from here. So after you load the script, you can either do this like that, or you can do this. You can do this. It's void, doesn't return anything, and it's just called Lua func, and then you can call like this. It really depends. Personally, I prefer this just because it's more obvious what's going on. As you can see, it calls this function. So you can make this function call this eval like this, and then you can imagine where this is going. Now that we have covered this, we can take a look at passing user-defined parameters. So for this, we create it's called CPP data. Let's say it's float x, float y. Let's just use int I. Now we want to use this struct inside Lua. So we can just register a new user type, which we can do like this. So you give it the struct or the class you want to expose, then you give it a name, and then you give it, you define the parameters, the fields you want to expose. So it's like this. So it's x, you give the pointers to it. And just copy paste a couple of times. Y, I. So now you have access to this in Lua. So in order to show that this works, we have to define CPP data. So now we run it and it works perfectly fine. So now let me do this. As you can see, it works. And now that this works fine, let us pass this struct to a newly defined function inside of our script file. Let's modify CPP data. Let's add the Lua prefix here, data, like this, and let's say we will just double whatever is inside the data. We will just double. So like so. A CPP data struct here. Let's call it data. Let's initialize to 20, 40, 50. A print function. Let's create a print function for the CPP data. pass in the data like this, and we just print it. We'll print this now. So we'll print this now, and then we will call the Lua function to modify it. So we will call auto modify, which is a std function of type void, and it receives once a CMake data reference, and we get it from the Lua state. And the function we want to call is called, no, not this, it's called like this. And we want to pass in the data. And we then once again want to print the data. Nice, so it works. Forgot to format this. Let's run again. Nice, so we create our struct here, 20, 40, 50. Then we pass it to Lua. Lua modifies the thing and then gives back the modified values. You can also define a function in Lua which returns a value. Lua return type. We can just define what we want to return. So now we can create one of our CPP data types, and we can say and return here. And now we can call this function from here, and we can also do the same trick thing. Return type. I mean, the names don't have to match, but it's kind of nice. And it actually returns one of those things. Yeah, and this has to be a reference. And now we can call the function like so. And we can print the data, so it will be like this. Yes. So we can insert a breakpoint here, and we can go inside here, take a look, it works. Oh, cool, this concludes C++ calls to Lua, and Lua calls to C++ with parameters, native parameters and custom structs. So next I will be talking about classes, and say we want to expose a class which has member functions. To do this, let's still use a struct 2, and let's give it an integer, another integer, like a constructor which takes and pass them around. Right, so now we need to expose this thing, and let's say it has a function which is something like void print numbers xy. So now we can go inside here, and we can do the following. In order to create constructors, you have to use the constructors function. Here you define the constructors, so as a void constructor, which it does not have, but I will create one. And it has one with 2 integers. So those will be called accordingly. And now we can expose also the data, so that we do it like that. Stuff is available also in the script file, and from here on we can just go like, I want to go inside here struct, and then we can just create a new one. We can do the following then, like this. Let's check where we are in the script. Okay, so it doesn't do anything because this is not initialized. In our struct we're not assigning those values to anything, so they're undefined, uninitialized, and so this is why it prints out garbage. If you do it like that, it should say 0, 0. And we can verify that this actually is the constructor we're calling. So it's 1, 2. And now let's call the other one. Let's call 6, 7. And it calls the right constructor. So this is, You can also expose member variables the same way. So it's pretty straightforward. Once you get the pattern of it, it's pretty easy. So let's call it print members, and then we say struct2 print members. Let's reformat that. Let's run and do struct members. Oh, yeah, it's like that, right? It's probably right like that. Yeah, so this is the OOP version. This is like we would have to do this, if I'm not mistaken. Yeah, so like if you use a double colon, you're passing self automatically inside it. So this pretty much covers it. This and next topic is gonna be the JSON alternative. The thing with that is that you can create, let's call it data.lua. Since this is a Lua script, which you can immediately just return a table, which in Lua is basically an associative array. So what you can do here is now you can say stuff like, okay, name is my name, age, I don't know, 12. And now let us define another table inside of here. And here we can say, for example, favorite books. And this can be also a table where we will just fill in some string values. The script file function has a return value, which in our case, in this case, it doesn't have a return value. So it's void and we don't capture it. So, and with the data.lua file, we return immediately a table. So we can just capture the return type and use it to access the fields inside of here. So we can go here and we can get the string name, which we define in the table as name. And we can verify that this is indeed the name. We can see that indeed it is my name. So it is actually the thing. And from here on we can also access, let's say, the data and favorite books by like so. We can do the same trick we did here. So this time this will be data and we will say data. Let's say table data. Oops. And inside the table data we have the favorite books array. It's also a table and it is fav books and it's inside the table data under favorite books. So and here we can access them like this, because we know this is an array. We could just also do the following thing. Let's park this here. Size, and then we can increment it, and then we can string book title, and we can say, and we can say book title is the following thing. To do cstring first. Yeah. So the thing is that Lua has this quirk that the index of arrays starts not at 0 but at 1. So, and we will have to do this. Now we will see that it works. And we can add book D just to verify that it works. So that's how you can use Lua as a JSON alternative. And also you can say let's just call it func. It's a function amount and you return twice the amount. I forgot the comma. Yeah, so what we can do now is we can say amount, and we can say table func, and we can give it 10, and then we should receive 20. Yeah, I'm not gonna do the casting here. Yeah, so you can get 20, and so as you can see, using Sol2 to bind Lua is super easy. They also have a great documentation, so you can just have a look. I really enjoyed using Sol2. I am also using it in one of my personal projects where I am using Lua as a JSON replacement format. And to come to the end of this video, I would like to ask you for some feedback. I want to know what's your opinion on the speed of the presentation. Am I explaining enough? Was the style too improvised? Should I prepare more ahead? Yeah, to leave me some feedbacks, because I enjoyed doing this and I plan on doing at least one more. So for the next one, I'm planning to do a similar type of video for PyBind 11, which allows you to bind C++ code to Python as well. So I will show you that. I will show you how you can use it as a scripting solution for, let's say, a plugin system or something like that, for an editor or for a game engine. I will then also show you how you can compile your C++ library so that you can use it in Python. You can debug C++ code and Python code in a mixed language way in Visual Studio, so you can put a breakpoint inside the C++ one and the Python, let's say, and then you can, when you hit the breakpoints, it will trigger the debugger there, so that you can see the state of your program. Yeah, thanks for watching again, and see you next time.